Today we're looking at proportionality theorems. We're going to use theorems about parallel lines and angle bisectors within triangles.
If I have a triangle and I draw a line that's parallel to one of the sides of the triangle, this is called the triangle proportionality theorem, and it will divide the sides proportionally. Now I want you to look at these parallel lines here. If I take Q and T, those are corresponding angles, so those are going to be equivalent. S and U are also corresponding angles, so those are equivalent. And both triangles have a third angle R that is the same. So these angles are all the same, so these are proportional triangles. So if I take RT over TQ, that is going to be equal to RU over RS. The second one says the converse of that side splitter theorem, and it says that if there's a line and it's dividing the triangles proportionally, then that TU has to be parallel to US because the sides are proportional, so they have to be similar triangles. So RT over TQ is equal to RU over US, and those lines are parallel. If I have three parallel lines and they are intersecting two transversals, they are also going to divide these transversals proportionally. And we'll get more into that in a couple examples later on. But what happens is if I take UW and I just label that there, UW over WY is going to be equal to Vx divided by XZ on that three parallel lines theorem. And those R, S, and T will all be parallel. The last one here is the triangle angle bisector theorem. If I take an angle and I divide angle C exactly in half, so those two angles are the same, these are going to be proportional to each other. So if I take side AD over side BD, and let's just highlight those colors, that is going to be proportional to CA divided by CB. So if I take AD over DB, that's proportional. That's going to be equal to CA over CB. Now let's set up some proportions here. I can set this up in multiple ways. If you notice, BE and CD are parallel lines. We are looking to find the length of AB. So what I want to do is I just want to put in an X for AB. We're going 5 over 10 is equal to X over 6. We want to cross multiply. 10 times X gives us 10X. 5 times 6 gives us 30. So 10 times X equals 30. So X is going to equal 3. If you notice, if I take 5 times 2, I get 10, and 3 times 2, I get 6. So this is proportional in different ways. I could have set it up in different ways just as long as the proportions are correct. So on this one, let's start with 2 over 9 is equal to X over 7. That X is going to be that AB again. 2 times 7 equals 14. And 9 times X is 9X. I'm going to divide both sides by 9, and my X is going to just equal 14 over 9. On example 3, I'm looking to see if AB is parallel to XY. So I want to set up a proportion. I could say 3 over 4 is equal to 4 over 5. I put that question mark over the equal sign because I'm asking a question. Are they equal? So if I cross multiply, 3 times 5 is 15. 4 times 4 is 16. Those are not equal. So these cannot be parallel. They're not parallel because they're not proportional. On this one, I'm going to take 4 over 6 is equal to 5 over 7. Follow that with your eyes. 6 times 5 is 30, and 4 4 times 7.5, I'm just take the calculator out. 4 times 7.5, we end up getting 30. So 30 equals 30. So yes, they're proportional and BA is parallel to YX. So on 5, 6, and 7, we are using the diagram to complete the proportion. If I take UV over UW, this is going to equal XY over what? I want to make it so it's the same on both sides, so I'm going to have XZ on the bottom here. My next one, I'm going to take XY over YZ is going to equal what over ZW? Well, we've got to have that same thing on top. So if we start with XY on top over here, XY over YZ is going to equal UV over VW. So we're going to put a UV in here. Okay, my next one, I have my full proportion is second. So I'm going to start with that full thing. WU over WV is going to equal what over ZY? And that would be the XZ. We want to get the same shape basically on both sides. Okay, so looking at 8, this line right here has divided this angle in 2. And if that happens, we have 2 proportional triangles. So I can say that x over 9 is equal to 5 over 15. Now I want to show you, if I had have set it up in a different way, let's say I did 9 over 15 equals x over 5. And I want to cross multiply here. I get 45 equals 15x. On this equation, I also get 45 equals 15x. So it doesn't matter how you set them up, you'll get the same equation for both. If 15 goes into 45 3 times, so x is going to equal 3 here. Now 9 is a little bit tricky. Let's pretend instead of a B here, I had a 6. We need to figure out what you would get for this side here. The whole thing is going to be 14. But if it was 6, I would take 14 and subtract 6 to get 8 for that left-hand side. So, but I don't have a 6. I have a B. So I'm just going to erase that 6 and I'm going to put 14 minus B, and that's going to be this left side. And the right side is just going to be a B. So let's set up a proportion. 6.75 over 14 minus B is equal to 9 over B. We're going to cross multiply. 6.75 equals 9 times 14 minus B. Sorry, this should have a B here. So I take 9 times 14. That gives me 126. 9 times negative B is negative 9B equals 6.75B. I add 9B to both sides. I have 15.75B equals 126. I'm going to take and divide by 15.75 on both sides of the equal sign. And in my calculator, I'm going to go ahead and put 126 divided by 15.75. And we get 8 for B. So what happens here is I get 8 for B here. And if I take 14 minus 8, this side is going to be 6.